My name's Ian Goodman. I'm the Managing Director of LiFeBATT Limited, the UK, Ireland and Southern Europe distributor for LiFeBATT. Today I have Steve from josbikes.co.uk, and we're going to run through the various aspects that you need to consider when you're installing a HPS, LiFeBATT HPS battery system into a motorcycle.
What else could we put them in?
Well, the same process could be used to do a car or a boat. It's the same methodology, and really, for all intents and purposes, we're doing exactly the same processes. We're going to put 4 of these units into the Ducati. So that's a 40 amp hour pack, capable of around 320 amps peak, 200 amps continuous. Here we have a negative terminal and a positive terminal. And on the front here, we have our data connection ports. Now this is where we can retrieve and send data to the management system built in this top section here. Now these are very important. We need to protect these packs, and we use these data ports to the pack level management system that will create the physical on and off at the controller or at the charger to protect the pack in the event of a low voltage or high voltage or indeed an over temperature fault. We can position it upright, on its back, even, upside down. Okay? The only thing we don't really want to do is on their sides. It can add a little extra pressure to the cells, and in actuality, you want these to last a very long time. So, if they can be positioned upright, that would be perfect. Steve, why don't you show us how we're going to mount these modules?
With these battery trays here, it's very easy to drop the batteries in so that they're firmly mounted, firmly protected from underneath. Then, using extra bits of bracketry, you can weld on and attach the battery pack, the battery tray, to any position that you need to.
How long is this going to take then?
I would think about a day and a half to mount the batteries and all of the components necessary, the controller and the battery protection module, and from then on it's just to wire the bike.
Well, cabling up the parallel modules shouldn't take more than a couple of hours once you've actually got your cables made. So here we have our 16mm welding cable with our tinned copper crimp, nice and secure. Now it's very important that these are insulated correctly. So we use heat shrink. Let's go over the top. We force it down so we have a nice clear terminal, but lots of insulation so it protects the cable. This is our marshalling box. We have a brass bar that's been drilled with 6mm holes, and we are bolting the tin copper crimps straight into the brass bar to create a strong, secure electrical connection. And before we close up, between the two there, we'll put a nice big thick sheet of acrylic so that we are insulating the positive and negative side of the battery.
Okay, we'll have to work this out. Well, it's a 6mm drill. That's right. We weld that onto there, and we then have 2 straps coming down, one from here down to the bottom of that battery box. There we go, it looks rather strange, but it should work.
So what we're doing here is covering up all of the terminals that are part of the marshalling box. And we'll go around, connect up all of the positives, then all of the negatives, and then fit the marshalling box securely underneath the controller panel that we're using. And we just remove the bolt. You can see we've got the spring washer and the washer. And when we're tightening these up, we're going fairly tight, but all we need to really make sure is that the washer and the spring washer are properly compressed, and then give it an extra turn just to make sure. We're going to cover up the terminal again, just in case any metal comes past to make a short. Put a washer in there and a bolt. And we'll put the spanner in underneath. Here we have a 300 amp fuse. That's the final component to go in. Because we've got a 40 ampere hour pack, and we know the pack can comfortably pull 400 amps peak, but we don't really need all that power. Fitting a slightly lower rated fuse just to be on the safe side. So Steve, perhaps you could take us through the various components we've got in here and explain why you chose them.
Okay. Well, this here is the Kelly controller. I've chosen this controller in particular for this bike project because it feeds the motor very, very nicely. It has excellent throttle response for a motorcycle, which is very important. This is protected here by a kilovac contactor, which is one of the nicer contactors on the market. It's very, very low current draw and can disconnect very, very high currents at need. This is connected via the kill switch, so in the event of an emergency it can just be turned off like this. To power this motorcycle, we've chosen this axial gap permanent magnet motor, which has an excellent power to weight ratio and can put out perhaps 40 horsepower peak and 20 horsepower continuous. It's extremely torquey and makes it a very, very good motor for an electric motorcycle.
And off we go. I think we can say that's a success then.
LiFePO4 batteries, the technology that LiFeBATTs are in fact made of, can enjoy a very, very long cycle life, perhaps up to 3,000 cycles. In order to do this, they need to be carefully monitored and protected to make sure that they don't go above their recommended voltage or below.
So we have this little unit here, our BPM, which is providing all the protection the pack needs. We've got our various indicators on the front here. We've got the power, the data and the two fault circuits, making sure that the battery investment is protected. The BPM has power to it, but is showing that the cables are not connected to the battery pack. So here we go, connecting the battery on. Again, it's reminding us that something has changed, and if we press reset, it's now confirmed it's made a data connection to the battery pack. We've got 4 modules of 4810 HPS. We've got 2 up the top here and a further 2 across the chassis down here, held in very securely with this nice strong steel frame and compressed at the top here, holding them in place. We've got the power connections, very important data connections here, and as you can see we've got the Zivan NG1 charger here, which with this size pack we can probably get a full charge in about 3 hours.
Is there any way I could have a faster charge for the batteries?
There is, absolutely. We can quite comfortably charge this pack in an hour. Unfortunately, it's too big to go on the bike. But yeah, 1 hour chargers, no problem at all. You can keep them on the wall in your garage at home. So, after 14 hours hard work, all the mechanicals are done, the powertrain's running. Just a few more cosmetic things to do.
All we need to do is fit the fairing and the seat and the tank to keep everything waterproof, dry and covered up and make it look pretty like a Ducati should.
There we go, job done.